Hello everybody. I've been away for a bit. Well, I haven't really. I've actually just been busy with other stuff. Haven't done a video in like 2.5 months. I think it was start of December, which is far too long. Yeah, December was busy getting ready for Christmas, and then January I had a really nasty cold, which took a while to get over. So here I am back again. Today I would like to do a quick little video on inverters. As you know, I've got a bit of a thing for solar powering my shed. I'm experimenting with solar power, and with solar power you charge your batteries, and then if you need mains voltage you need to use an inverter to get up to 240 volts in most of Europe, or 110 volts if you're in the States, or whatever your voltage is in your part of the world. So this is a little quick video about crappy inverters and what to look for. I'm not really going to go into a lot of theory or a lot of detail, because this isn't what it's about. It's just basically how to spot a crap inverter, and also talking about a little lesson I've learnt buying a crap inverter of my own. So yes, about a year ago I bought this on eBay from a UK supplier. I think it was £35. Now there is my first mistake, because generally I've noticed with inverters that there is a price point versus quality. So for example, this is an inverter I bought in a shop called Maplin's, which is a UK chain of electrical stores. Think like Radio Shack, but a lot more technical. 150 watts. It cost me €39, say €40. And a 300 watt version costs €60, and a 1 kilowatt version is €110. So generally there is a price point. So if you wanted that, you should expect to pay for a certain level of output from the inverter. So I'm going to say €100 for 1 kilowatt, or whatever it is in your local currency. Right, so buying this for £35, which is about €45, was, I don't know why I did it, to be honest with you. I think I was just curious just to see how crap it was. So anyway, it came in a brown box, no leaflets, nothing. And it took me about 2 or 3 months to actually take it out and test it, which was my big mistake. You should always test your stuff. Pardon me. Made in China, dodgy CE mark, which is sorry, I've got a blocked nose there, which isn't correct, because I believe some people say this actually means China export, but it's not the official CE mark. 12 volts, 230 volts. Well, interesting little thing is that actually in Europe the acceptable level of voltage is between 220 and 240 in the mains. So that means that any appliance made anywhere within the European Union should work, because some parts of Europe are 220, some parts 240, so 230 is kind of the middle ground. First of all, I'll actually have a look at this one here first, to sort of give you a comparison. I'm quite happy with this. It's heavy. Like, this is actually slightly light. This is slightly heavier than this one, which is what you don't expect. It's got nice ribbing for the heatsink on the side, so that's what you kind of expect. And the socket is, it's a proper BS1363. I need to check that socket, in that there are shutters on the live and neutral, and you have to push an earth pin in to open them. That's correct, that's the way it should be. Secondly, there is an earth point on the outside. So like if you're using appliances that have an earth, so that's something metal bodied. So basically something that doesn't have a plastic earth pin on the plug. You should really earth this and know what you're doing. And I'm just going to do a quick continuity check to show that yes, indeed, the earth pin is connected to earth. Oh, actually going into continuity mode would help. There we go. So put that in there. So that's the way it should be. This is quite a nice little inverter. Does the job. I can power my laptop, my radio gear, and a big monitor off this, because they're fairly low power drain. This, on the other hand, has this absolute monster of a socket, which is incredibly dangerous. Like, I notice a lot of stuff that comes from the Far East. They try to sort of make these sockets that accept everything. Now, if I got an old cheap and nasty one power plug adapter here, yes I do. As you can see, same sort of thing. quite dangerous. I wouldn't mess around with these. I wouldn't use them because you should have shutters on the live and neutral. But there is earthing there, but there's no earth anchoring point on the device. So let's see if there's continuity on the earth. I'm not hopeful that there is, so I'm going to put that in there. Nope. Try the other way around, just to be on the safe side. So yeah, there's continuity on the negative port. Let's see. I don't think so, but you never know. Nope. Rubbish. So basically, yeah, I had this about 2 or 3 months before I actually tested it. I plugged it in, nothing. Now the only lead it came with was a set of cheap and nasty leads with circular crimps on one end and crocodile clips on the other. So it was designed to attach directly to a battery. I replaced it with this because it makes it easier to attach into my setup here. So yes, without further ado, let's actually open up this thing, see what's going on inside. Because oh yeah, sorry, I meant to say, when I did actually try to test it, it didn't work, and it has never actually worked for me at all, and I'll show you why. Yeah, so I dismantled this a bit more off camera. It was a bit harder than expected because this thing there slides into a rail here, and this was bent, and dismantling it made me look very awkward and silly on camera. So here we are. First impressions are, it looks cheap and nasty, and well, that's kind of what I expected. Before I continue, I'll just give you a very basic rundown of how an inverter works. This is a very high level view, but every inverter is slightly different. But you get 12 volts coming in from your battery. It goes to an oscillator, which could be something like a Colpitts oscillator, a Hartley oscillator, or one of the sort of generic sort of oscillating circuits that everyone learns when they're studying electronics for the first time. Or it could be a chip or a custom solution, who knows. But I'll go for an oscillator which will generate an AC waveform. Then it'll go through some kind of amplifier circuit. That could be a MOSFET, or again some special chip or whatever, and that basically takes the 12 volts AC up to maybe 48 volts, which when it goes into the primary and secondary winding makes it easier. The windings don't have to be so far apart in terms of size, and then you get 240 volts out. So really quite simple. In reality, you'd have a lot of circuits, extra circuitry in this. You might have circuitry to check the output voltage, and if it gets too low or too high, it might shut it off or give a warning. Or you might have some sort of switch mode power supply sitting here, which varies the, so if the input voltage is too high, it might drop it down so the rest of the circuit is getting exactly what it expects. Or if it's connected to the mains, like if you're using it to supplement mains voltage, there might be some sort of circuitry to detect if the mains supply has failed, in which case you want to cut it off because you don't want to electrocute the people working on the mains grid outside your home. So there you go. But here it is. Let's have a quick look at it. So the power comes in here from the battery, and oh, look at, oh, sorry about that. Look at that nasty bit of soldering. That is horrible. Really nasty. What you have here is two 40 amp car fuses, and there's nothing wrong with using car fuses. They're used a lot in amateur radio for protecting radio rigs, but generally you'll have a special fuse holder attached into the positive lead of the power supply. What we have here is crimp connectors. That is nasty. That's horrible and nasty, because they aren't designed for taking fuses. They should have a proper fuse holder soldered to the board here, but they've cut corners, and the problem with that is getting the fuses in bends and twists them, and you might actually break the fuse wire inside before you even had a chance to put any power through it. But secondly, they're using two in parallel. Using fuses in parallel is ill-advised. There's nothing specifically wrong with it. It's just ill-advised because you have to make sure that the paths into the fuses are identical, because electricity takes the path of less resistance. So the leads coming from your battery and these leads here coming in would have to be identical to make sure that there's no more current in one path than the other. And if there is, then one fuse is going to blow first, and then the other one's going to blow along with it. Because yeah, two 40 amp fuses in parallel is an 80 amp fuse, but what they should have just used is a 80 amp fuse here instead of two 40 amp fuses. They were cheap and they were nasty, especially using these Crimp Connectors. That is horrible. Like I said, I'm not going to too much detail on the theory of it, but just looking at it, it does look nasty. But the thing which I did do was I checked the thickness of this power cable coming in. It looks nice and thick, covered in silicone, but the actual, when I put the calipers onto the bit of wire here at the end, it was 1.52 millimeters, which is American wire gauge 14, and the amperage there is, that thickness of wire can sustain 15 amps. Pardon me. So although yeah, it can take higher bursts for short periods of time, it's ill-advised. No, you don't want that. It's, the wire coming in should be chunkier, to be honest with you. There's a risk of it burning, the actual wire itself becoming a fuse and burning out, and not the actual fuses. The other thing that caught my attention was the plug. I mentioned earlier that there was no earth continuity on this. Well, if you look at the plug itself, look at that. Earth's connected to nothing. And look at the wiring coming in. It's both red, so the live and neutral they both have red wires, which is ill-advised because no, it's just bad practice. Okay, I know you can sort of check yourself. You can see what prong it's going into, but oh, that's my reminder to remind me to turn off my alarm. Yeah, it should be black and red. It's just good practice. And also the thickness of these wires, again, way too thin. This is the sort of wire you use when you're building something with an Arduino using 5 volts. This is not the sort of stuff you use for powering a 240 volt socket, or sorry, in this case 230 volt. So yeah, nasty. Now the thing is, with this inverter here, 150 watts, it does have earth. The earth does have continuity to the earth pin, but you probably wouldn't need it because the chances are you're going to be powering stuff like laptops, small televisions, mobile phone chargers, and they are insulated items, products. They don't need earth. They have a plastic earth pin, so you don't need earth continuity. If you're using a 1500 watt amplifier in a caravan or a motorhome or camping, the chances are you're probably going to be trying to power up a microwave oven or a toaster oven or something that uses about 1 kilowatt, or maybe a slow cooker or a small travel kettle. Those things do require earthing, and there should be an earth connector on the body of this device that you can attach up to the body of your camper van or the body of your car. As it stands, if you were to plug a microwave oven, which uses about 700 watts into this, it wouldn't be earthed. But you need an earth, something like that, or the kettle, or whatever. So that in itself is pretty dangerous. So would I describe this as deadly? Actually, yeah, potentially, yes. For multiple reasons. The lack of earthing for something in this sort of power range. If there is earth, you should be, and you're using this in a caravan or a motorhome, you would attach that earth to the body of your caravan and you'd probably also use a residual circuit breaker, an RCD, to cut any current. No, if there is a problem, to cut the flow of electricity. But you also need to earth it. The wiring is just too thin. The horrendously bad soldering, which could melt as well, and these nasty fuse holders, which aren't fuse holders at all, they're crimps. So oh, there's very little light here, sorry. Apologies. So yeah, just generally, like, it's cheap and nasty, and stuff, they've soldered stuff on that should be bolted on. The circuitry is a bit too close together. I would like to see a bit more separation between 12 volt side of it and the mains side of it. This wire here is just too thin, way too thin. And like I say, learn from my lesson. You get what you pay for. If you're paying 30 quid, 35 quid for a 1500 watt inverter, you're probably going to get crap, and I did. You get what you pay for. So there you go. Cheers, take care, bye bye.